let me call Hakan to the stage. Can we give him a round of applause?
Cool. Okay, let's get started. Hey everyone. First of all, let me quickly introduce myself. I'm Hakan. I work as a global solutions architect at Arize. So basically what I do at Arize is like I work with most of the AI teams globally and then kind of help them integrate their like Gen AI use cases into Arize, help them understand like what Arize does, and then like how basically like our platform, whether it's open source or enterprise, can help improve, evaluate, and iterate on their Gen AI use cases. And then specifically for today, I want to focus on RAG pipelines specifically, even though we focus on like a bunch of different stuff like agents. I want to focus on evaluation of RAG pipelines. So let's get started. So I always like start pretty much all my talks with this specific slide because this is pretty much like the biggest challenge we see in the AI space right now, where like a transition from a Twitter demo to a real product is very hard, right? So as you know, like if you use something like LangChain, Llama Index, Crew AI, whatever it is, it's actually really easy to build some sort of demo in just a couple lines of code, right? If you want to do some RAG, some chat on your docs, etc., it's really not that hard to get an application up and running, even with a simple front end. But the main challenge is like actually making it, turning into a real product that like some internal or external users can actually test, ask questions, or basically just leverage your application is very, very hard. So what I want to actually talk about is like, first of all, like what is driving this challenge and big pain? I kind of want to do a deep dive on that. And then basically talk about like, what are some different open source tools you can use so that this transition is basically as not hard as it sounds. So let's get started. So if I look at actually like not even RAG, right? If I actually look at all the use cases that we see in production or development, there's like one big pain across all developers. And that's basically the fact that any small change that you make to your application can cause actually huge performance regression. So imagine like you're building a RAG application or an agent, and then like you're basically testing stuff on your with your users, and then you want to change a prompt, you want to change a model, right? So as you make changes to your application, you might be kind of like fixing a specific problem you had with your users, but it's really hard to tell like if you broke another use case or if you did something else. So there's basically a need to quantify these changes that you make to your application so that you can actually say, okay, this change that I made to my application is actually better than my previous setup. It basically gives you a way to continuously iterate on your application, right? So this is kind of the biggest pain that we see, like the lack of ability to quantify these changes. And in terms of how to solve this big pain, we kind of like recommend this like evaluation-driven development approach. So what is evaluation-driven development, right? So if you have actually worked in software before, there's this concept of test-driven development, TDD, where you actually write the unit tests, the test itself, before you actually write the code itself or make some changes. Because this testing or the test that you write will drive your software development process. In the case of Gen AI development, it's actually very similar, where you actually use an evaluation-driven development, EDD as we call it. And the main idea is you should first, actually, even without the data set, like in test-driven development, you first create the tests, right? In evaluation-driven development, you actually first come up with some sort of evaluation criteria in order to kind of evaluate your application. And we're actually going to talk about how that evaluation works, but the first thing that you need to do is like, first of all, like understand what you want to evaluate and what you want to quantify. Is it hallucination, toxicity, or anything that's like important for your business or application? And the way this kind of approach works is you first need to have a data set, right? So this could be a data set of examples, like a golden set of examples, or like, let's say 100 user questions that you expect users to ask. This can include some bad examples, positive, negative examples. It's really up to you how you create this data set, but you need to make sure that this data set actually kind of covers different use cases, different user questions, and some edge cases as well. And what's gonna actually happen is like, as you get to production, this data set will dynamically grow. This is actually not expected to be a static data set. This data set should always grow over time, your testing data set. But let's say you have like 100 user questions that you want to test on your RAG application, right? So then what you do is, anytime you make a change to your application, you kind of treat that as an experiment when you like change the model, change the prompt. And then from there, you actually run your experiment on top of that data set. So let's say you change the model, you change the prompt, you basically run the new setup on top of those 100 questions, and then finally you evaluate the experiment itself so that you will basically end up with some sort of score, right? So that you can say that this change that I made to my application improved my hallucination rate, let's say by 30%, etc. So that's kind of like a high-level overview of how this evaluation-driven development works. So in order to kind of like understand this a bit better, let's actually talk about evaluation, right? So first, I'm going to go to like first a very quick RAG architecture. You already said that most of you already work with some sort of RAG application. This is pretty much the most simplest you can get. Just for the sake of simplicity, I'm going to focus on this today, where you have a user question coming in that gets turned into an embedding, and then you go through that goes to a vector store, and then this vector store can contain text, multimodal data, unstructured data, really depending on your setup. And then after some search and retrieval, you retrieve the most relevant context from the vector store by looking at the query embedding. And then finally, you create a prompt using the user question and the context, which gets fed into an LLM so that it provides a response. So this is kind of how it works. Again, it's actually not very hard to build this if you use something like LangChain, Milvus, or OpenAI. Again, very easy to set it up, but then the main challenge is, okay, how do you actually build up or like kind of have this EDD process set up? And again, that comes with evaluation. So let's talk about how to actually evaluate this pipeline. So first of all, like, who here is familiar with the concept of LLM-as-a-Judge? Okay, quite a few. That's great. So the first thing that you like, I guess, if you think about like most of the AI teams right now, what they do in terms of evaluation is they basically leverage another LLM as a judge to evaluate their input and output. So the main idea is you have your RAG application here, you have your input coming in and output coming out. And then what's going to happen is you will take your input, you will take your output, and you provide it into an eval library. This could be our Phoenix open source library or anything. I mean, Llama Index even has their own evaluation library here. And then what's going to happen is you're going to use another LLM as a judge to evaluate the input and output. And then this criteria for evaluation will be actually defined in the eval template here. So at the end, based on this eval template, an evaluation output will be generated. And usually the most common question I get is like, oh, like what LLM am I going to use to do this evaluation? Well, it's usually up to you, but I would actually recommend that you use the same LLM, like let's say GPT-4o or Claude or whatever you're using to do the evaluation as well. Like use some actually like a good complex model if you can, because if you think about it, the task of evaluation itself is much simpler than actually the generation and reasoning stage. So it actually works pretty well, even if you use the same LLM that you use your application with. And that's kind of also what we recommend in production. So let's kind of look at an example here. Like, how does this actually LLM-as-a-Judge work? So let's say that what I want to do is like, I want to quantify my retrieval stage, right? That's my first stage in the RAG pipeline, which is retrieval, where you have some user question coming in and the output is some sort of documents. So you basically get the user question and documents provided to an evaluation library where you have this eval template here. And this eval template basically looks at the question and the reference text and asks the LLM as a judge to basically check if the question is relevant to the reference text and also provide an explanation. So based on this eval template, it's going to provide an output, something like this, irrelevant and irrelevant, so that you can actually kind of have some sort of metric like relevancy rate, or I mean, I'm also going to talk about ranking metrics in a bit, but you actually have some sort of metric here to check if your retrieval is working or not. So that's kind of at a very high level how LLM-as-a-Judge work. And if you kind of look at this for the whole RAG pipeline, we usually look at two types of evaluations, right? So we already talked about the first one, which is relevancy evaluation, where you check, is the retrieved context relevant to user query? And there's also a second type, which is the generation piece, where you also look at the response and evaluate the response itself. So that basically checks for hallucination and Q&A correctness, where you can actually check, first of all, is the response hallucinated based on retrieved data? So in hallucination, what we're actually checking is it faithful to the context I retrieved, right? Is it actually getting the right information from the context, or is it just making stuff up? That is what hallucination is. And in terms of correctness, it is a bit different than hallucination, even though sometimes it is very similar, where it actually checks, is the response correct, right? Because it might be faithful to the context, but it might not actually be like completely correct. It might be missing some information from the context. So it's really important to check for correctness as well. So by having all these three evaluations, relevancy, hallucination, and Q&A correctness, you really can easily quantify the quality of your responses in your RAG applications. So let's also talk about like some unstructured RAG, where you actually have some unstructured data, and then you actually want to kind of do some sort of in-depth analysis of your RAG application, right? That's where the embeddings comes in, right? Because embeddings is basically the core foundational data modality of RAG applications. So what we thought is like you should have a way to leverage those embeddings to actually understand like specific gaps within your knowledge base, and especially if you have something like unstructured and multimodal RAG, you can actually kind of even use those like embeddings, like multimodal embeddings, to kind of really understand like what's happening there. So I'm also gonna show a quick demo on this, but it's very important to leverage these embeddings to your advantage as you troubleshoot your application itself. So that's kind of how you evaluate and basically troubleshoot your RAG pipelines at a high level. But let's actually kind of jump into a demo. So let me jump into Phoenix. So first of all, who has heard of Phoenix before? A few people. Okay, cool. So Phoenix is our open source platform. It's actually fully open source. You can just pip install it. We do have a hosted version if you want, but fully open source. You can get started anytime you want. And what I want to do is like, I want to kind of go over the concepts that I just showed using Phoenix. So in this case, we actually have, let me kind of zoom in. Okay, that's better. So we actually have a RAG application here. And this is actually a RAG application built on the Phoenix documentation. So people actually ask questions about Phoenix, like, can I use gRPC? Is hosted Phoenix free? What is the data retention policy, etc. So as people use your application, you can actually connect it and integrate it into Phoenix with just a couple lines of code that will correct your telemetry data so that all your basic questions will show up here, right? So you basically have the input, the output, as well as the evaluations here, which I'm gonna show in detail in a second, as well as the latency and token usage. So you basically have all your data that's incoming here as people use your application. And the cool thing is like, if you actually click on a specific trace, you're actually gonna see what's happening behind the scenes one by one. Like, so this is actually an application built on Llama Index. So because of our integration with Llama Index or LangChain, it will automatically pick up all the telemetry data in terms of what's happening behind the scenes. So for example, like I got this question, can I use gRPC for trace correction? The output is you can use gRPC. But if I can first check what documents I retrieved to actually answer this question. So I retrieved this document, and then you can see that I actually evaluated it, and it says this document is unrelated, and also gives me an explanation on its relevance. The second document I look, this is also unrelated, and gives me an explanation. And then the third document as well, and it goes on like that. So you can see all the documents that you retrieved, as well as the LLM call that was done at the end. Sorry, this one. Including the system prompts, the user prompts, and everything is automatically shown here. So we have full visibility, like the tokens and everything step by step on how your RAG application provided that response. And then at the top here, you also have your hallucination and correctness evaluations, which I just talked about. And then the cool thing is like Phoenix will give you an explanation like of why is it hallucinated. So it's gonna say like, the query asks if gRPC can be used for trace correction. The reference text discusses tracing in detail, including the components and OTel. However, there's no mention of gRPC, right? So it actually says like, the text does not answer your question, but your output says you can use gRPC. So this just doesn't make sense, right? So this is a hallucinated response. The answer is not correct, hallucinated, and that is mainly because you basically did not retrieve the right context. So that's kind of like the tracing and evaluation piece where you correct your telemetry data and then you start to run evaluations on top of it. And then you can even like, if you want, like annotate these, like provide some sort of human feedback from your internal users. Some like contractors might come in and also provide their own feedback. It doesn't always have to be like generated from an AI. Very flexible in that sense. And then most importantly, you can also kind of like say like specific traces to a data set. I can easily focus on all hallucinated examples, and then I can pick them all, and then I can save them off as a data set so that I can actually kind of iterate it as an experiment, right? So you can also curate your data set or basically grow your data set using these traces as well. So the next question is, the main next question I have is like, okay, I have this tracing and evals. It actually helps me find some good responses. How do I actually kind of iterate on these, right? So this is also coming on Phoenix. It's not released yet. I think this week we're releasing it, but on our enterprise platform, you can also like jump into the LLM spans and then jump into a prompt playground where you can actually iterate on your prompts. So you can actually kind of like say something like say, I don't know, if you don't have the reference context. So say,
may I ask a question?
Yeah, I have like 5 minutes at the end for questions. Okay. Yeah, no worries. So you can actually run this on top of it, and then you will actually be able to see like if it fixed the hallucination, and in this case, it actually did, right? So I can talk about these later, but just want to show this as a next step. But most importantly, what I want to actually get to is the embeddings piece that I just talked about, because once you actually have all these, you also have these embeddings that are collected here, right? So you can actually use those embeddings to your advantage. And then what you can actually do is you can actually take those embeddings, apply a dimensionality reduction algorithm, and then visualize it in a three-dimensional space. So this is kind of like, if you think about this is your RAG application visualized in a three-dimensional space, where the blue points here are your user questions, and the gray points here are your like document chunk embeddings. So it's basically like embeddings of your knowledge base, and the questions are here. You can kind of go in, zoom in, play around with this, see the specific question and response, as well as the documents that were retrieved. But most importantly, what you can do is, once this visualization is created, we also apply a clustering algorithm on top of it so that all these specific clusters are created on top of these points. And then you can pick a metric you're interested in. So I can, for example, pick like faithfulness average, relevancy average, user feedback average, context relevancy average, etc. Or I can just pick like accuracy score or something else so that you can actually find like the most problematic clusters in your RAG application. So for example, like if I jump into this cluster, it actually has questions about Arize pricing, like how much does Arize charge, how much does Arize cost, etc. And then this is actually a very good insight for my RAG application, because when I actually go back and check my knowledge base, I don't have anything about pricing. So here with this clustering approach and embeddings, Arize actually kind of, Phoenix actually kind of identified a gap within my knowledge base by leveraging these embeddings. So like at a higher level, you can basically use these embeddings analysis to like find the highest hallucinated clusters, highest toxic clusters, and then you can even export them, do whatever you want. Some people even use this for like fine tuning, and they go to that next step. But again, this basically embeddings view is really powerful to find gaps in your GenAI applications. And especially if you have some sort of multimodal RAG or something else, this is especially useful. So given that, that's kind of actually what I had for the talk today. Definitely check out Phoenix. It's pip install Arize Phoenix. Would also really appreciate if you give us a star on GitHub. But yeah, thank you so much. Question? Yeah.
Evaluation. Thanks for the talk. So the difference between test-driven development and evaluation-driven development, is it that test-driven development is like a binary thing. Like it either fails or passes, and evaluation is continuous, or what's really the difference?
I mean, it depends. You can still make this a binary. Like, for example, like you run an experiment on top of a data set. If it's more than 60% hallucination, fail. If it's not, pass. The main difference is like you actually use the concept of evaluation here, like LLM-as-a-Judge evaluation, instead of just doing normal like software checks. So that's one main thing. And then the second piece is like this data set of examples that keeps growing, right? I mean, the TDD process really depends on how you set it up and also on the software application. But the main difference here is you can treat it as continuous as well if you want, but the evaluation piece specifically, like LLM-as-a-Judge evaluation in this case.
Yeah, because the thing is, I mean, if you do this evaluation-driven development, you need to have the examples in advance, right? You need to set them up in advance. Also, running your whole pipeline again and again for all of these examples can be quite costly.
That's a good point. So, I mean, even like you can start with 10 questions, like, because imagine like, let's say you don't have this, right? You have some application. How will you test it? You're gonna put in some random questions, right? To see like if it actually provides a good response. This is kind of scaling that up and making it more automated and continuous, where you actually, like, instead of typing in random questions, just type it in a spreadsheet of 10 examples and then start with that. It doesn't have to be like thousands and millions of examples, even though that's like what most enterprise people do. But imagine like instead of doing it yourself, you kind of scale this and do it in a more automated, systematic manner.
Yeah, because the thing is, I was also thinking about if you want to test this, I have some set of example questions that have a very fixed answer. And I would just check if certain words are in the given answer. Like this is a, well, it's not necessarily cheaper because you still need to generate the answer.
Yeah, what you're talking about is the second type of eval, which we do have this. It's called a code eval, where you don't leverage an LLM to do the evaluation, which can be done. Like you like test it against the ground truth, you check for semantic similarity, specific keywords, regex patterns. Those are all possible, and it can still be followed using the same framework. But the thing is, like, as your application gets more complex, that usually starts not to work. Like you would actually need some LLM power to do it. And then if you use some like even open source LLM like Llama 3 or Mistral to do the evaluation in a simple lag case for free, that's also fine. I mean, that's also definitely doable.
Yeah. Yeah, but if you already have something like that's in development or production, that's not like open source on your own servers.
So, like, I'm talking about the open source.
Maybe that's not relevant.
I'm talking about the LLM you use to evaluate, basically.
Yeah. Thanks a lot. I have much more questions, but I'll come to you.
Okay, sounds good. Thank you.
Okay. Well, it looks like I got a question over here.
Cool.
Hello. I was curious, in the beginning you said that we can use the same model for the judge later. If I use some proprietary or internal data, like internal documentation, won't it also, and I use the same model basically that is also trained or uses the internal data, won't it also hallucinate that way? Like, what's the difference?
Yeah, so that's kind of what I alluded to. So there's like two tests that's going on there, because the task in your application is a generation piece and reasoning, because like in your application, the goal of the application is to understand the context, digest it, and then provide like a long response. Whereas the evaluation one is actually a much simpler task to basically just saying like, okay, this is relevant, this is not relevant, right? It's basically a much more simple task to do. So it does hallucinate, right? So it's not like this is a perfect scenario where like if you use an LLM, it's gonna always give you the best output. In order to get around this hallucination, what we do is we actually go to a benchmarking exercise for the top foundational models out there, where we actually do is like, we also have a golden data set, like of let's say 1,000 examples, just as an example, that also has like human labels attached to it. So then we basically check, okay, if I use like this specific eval template against this data set with human labels, how close does like GPT-4 or your own proprietary model get to human evaluation? And then we use like precision and recall to do this. So if you go through this benchmarking exercise, you can actually see like how much it is expected to hallucinate for the evaluation task itself. So definitely go through that benchmarking. I didn't get to it today a bit. That's a bit more detail, but it is actually a good practice to have some benchmarking in place, like your own use case and data set, before you actually start with LLM-as-a-Judge evals.
Thank you.
Thanks again, Hakan. So I think we've got time for one more question. So, I was actually going to abuse my position as the host to take that question, but I'll save it till after.
Okay. Thank you for the presentation.
Yeah, of course.
I have a question. So you showed us some of the evaluation metrics.
Yeah.
And those look like this RAGAS metrics. Is there a possibility to add custom metrics for evaluation?
Yep, there is. You have the option to create custom evals. So like, remember I showed the eval template here. So this is kind of an eval template here. You can totally customize this. Like you can build your own eval template. Like basically like that checks for like a very specific case, right? I mean, I don't know, like conciseness, something else, like any specific keywords. You can actually build your own eval templates and then have like Phoenix basically generate those evaluations for you. So that's totally customizable.
Thanks again, Hakan. Can everyone give Hakan a round of applause?
Thank you.